what up, guys? Welcome back to erbsclass, man, for 5 more minutes of math. So today, we're talking about graphing lines in standard form. Now, you probably already graph lines in slope-intercept form. This is usually what comes next. Standard form looks like this. Yeah, remember slope-intercept is where y was all by itself and y equals mx plus b. So sometimes you're gonna have x and y on the same side together. Yeah, so usually, probably always, the x term will come first, the y term will come second, and then that will all be equal to a constant or just a number without a variable over on the other side of the equal sign. Yeah, so this is just another way to see a line. If you watch my other video about line equations in the different forms, there are a lot of different ways to write the same line. So this is standard form. Yup. Now, this A, B, and C usually has numbers. Might look something like this. Yeah, exactly right. So now, the quickest and easiest way I've found to graph a line that's in standard form is by finding the intercepts. There's a video about intercepts. Please check that out. It's going to take you 5 minutes, but here's a quick summary. To find the intercepts in standard form, we use the cover-up method. Remember, to find the x-intercept, we said y equal to 0? Something like this. When y equals 0, that term is gone. 4 times 0 is 0. It's out of here. So to find the x-intercept, I write down what's left of my equation, like this. So just the x part will give me my x-intercept. And likewise, if I want to find the y-intercept, x equals 0, I cover up this part, write down that equation to find my y-intercept. Yeah, now one step later, now once I have my 2 intercepts, I'll just put those 2 points on the graph. Looks a lot like this. Bang! Put them 2 points on the coordinate axis, connect the dots with a line, and you have graphed in standard form. It's just that simple. Use the cover-up method to find your intercepts, put your intercepts on the graph, connect the dots. Yeah, there's one other way. Let me show you with this equation right here. Or you can move some stuff around in this equation, manipulate this equation, and get the letter y all by itself. I want to isolate y. I want to solve for y. That means get this letter all by itself. That's something that I can do. When y is alone and it just says y equals, that's in slope-intercept form, and we know how to do that. So there's a couple of steps. Actually, there's only 2. Step 1, take this x term and move it to the other side. Now, you can subtract it from both sides, but you're really just taking this 3x, moving it over there as a negative 3x. Don't forget to change the sign. Looks like this. Yes, it's like I'm subtracting, well, it's not like, I am subtracting 3x from both sides. But when I move it over there, they're not like terms. So I'm just going to write them down beside each other with the x thing first. Yes, just like that. They're not like terms. Do not combine those together. Leave them separate, write them down beside each other. Last step. There's one last step to get that y by itself. I'm going to detach that 4. That 4 is being multiplied. I'm going to divide to get rid of it. I divide everything by the number on y. Looks like this. Now, I could have wrote that all as one fraction, but I have 2 things up top, so I can split that. Both of them are getting divided by 4. Yeah. Now, this I can't necessarily divide by 4, so it's going to stay a fraction. I can divide that by 4. Final equation looks like this. Yes, and I guarantee you, if you graph this equation, it's going to look exactly like the one we had before. It's a little bit more work, but always another way to do it. I'll see y'all next time. You want some practice, let me know. Bye, guys.